Hey there, Mr. Weaver here, and this is topic 4A, lesson 2, and we're still dealing with parallel and perpendicular lines. After this lesson, you need to be able to create a parallel or perpendicular line given specific points to pass through. You'll know you're successful after this lesson if you can create a parallel or perpendicular line that follows the given criteria. So the first thing we need to do is make sure we can get our line to go through specific points. So here are some steps to do so. So first thing, you're going to start with point slope form, which is y minus y1 equals m times x minus x1, where m is the slope and y1 and x1 are your point. Then you're going to plug in the point that you're given and the slope. Remember, when you're plugging in the point, it looks opposite in the equation compared to what it looks like as the coordinate point. Finally, you're going to rearrange the equation and solve for y, and simplify it as much as we can. So let's look at an example of making a line that goes through specific points. So what's the equation of a line in slope-intercept form that's parallel to the line y equals 3/4 x minus 4 and passes through the point 8, 9? So some key parts that we need to know here. First, it's parallel, which means it has to have the same slope as we had before. So if we're following our steps, first we're going to start with point slope form. Then we're going to plug in our point and our slope, and then we'll solve for y. So we have our equation. Parallel means it has the same slope. So the original slope was 3/4, which means our new equation is also going to have a slope of 3/4. So let's plug that in for m. Now we want to get it through the point 8, 9. So we're going to plug in 8, 9 into our equation. So 8 is x, it goes in place of x1, 9 is y, it goes in place of y1. Remember, they should look opposite in the equation compared to what they look like in the point. So 8 should be minus 8, 9 should be minus 9. Now I need to solve for y. So to do that, first I'm going to distribute the 3/4. So 3/4 x, and then 3/4 of 8 is 6. So 3/4 x minus 6. And then to get y by itself, you just need to add or subtract, in this case add, the extra that was at the end to both sides. So add 9 to both sides. My slope-intercept form would be y equals 3/4 x plus 3. It has the same slope, different y-intercept, so we know they're at least parallel. Now that we have our equation, let's use Desmos to check to make sure that our line does in fact go through that point 8, 9. Alright, now let's use Desmos. So here in Desmos, we can check to see if we have a parallel line to y equals 3/4 x minus 4, and it had to go through the point 8, 9. So our equation we came up with was 3/4 x plus 3. So if I type that in, it does in fact go through 8, 9, and it is parallel to our original equation. So y equals 3/4 x plus 3 must be the correct equation. Now it's your turn. Pause the video and come up with the equation of a line parallel to the one given that goes through the point 6, -1. Don't forget, you can use Desmos to help you out. Check your answer. Should have had the same slope, 2/3, And to go through that point, it must have had a y-intercept of -5. Write the equation of a line that goes through 4, 5 and is parallel to the line that goes through the points 4, 2, and 8, 5. For this problem, let's enlist the help of Desmos. Alright, we want to find the line that's parallel that goes through 4, 2, and 8, 5. So I want a line that goes through those 2 points, but I don't care about that line. I want the line that's parallel to that. And I also want it to go through 4, 5. So parallel to my purple dots, but through my red dot. So first, let's come up with our equation of our purple dots. So I can see by counting from one dot to the other that the slope through my 2 purple dots, the line that would go through those, is up 3 over 4. So 3/4 x. I can see that's pretty close. In fact, if I were just to go down 1, I would be through those dots. Now, I don't care about that line. I want it parallel through the red dot. So I know that it has to be 3/4 x because parallel has the same slope. And to get it through that dot, it looks like I would just need to move the line up a couple spaces. So it was at 0. If I move it up 2, it is there. So the equation that was parallel, that went through the red dot, is 3/4 x plus 2. I could have also started with my point slope equation, plugged in what I know. So 4, 5, slope has to be 3/4. Okay, it shows me there, and then if I wanted to change it, y minus 5 equals 3/4 x minus 3. We can still see we're in the same spot. If I add 5 to both sides, I'm at plus 2. So y equals 3/4 x plus 2. So we had y equals 3/4 x plus 2. Pause the video, use Desmos, figure out the line that goes through 4, -1, and is parallel to the points -8, 0 and 4, 6. Check your answer. You should have got y equals 1/2 x minus 3. Next, let's look at a real example. A landscaper has been hired to install a path in a park. It must be perpendicular to the current path and lead to the fountain. What is his equation? So first, let's start with our point slope. We need to figure out what point and the slope. So our slope on the line, every time it goes up 1 over 5. So our slope is 1/5. We want it to be perpendicular for our new one. So we would make it the opposite reciprocal, -5 over 1, or -5. Then our fountain currently is located at the coordinate 15, 2. So if we plug these in, y minus 2 equals -5 times x minus 15. That's an equation we could use. It doesn't ask us to change it to slope-intercept form. We could keep it as that. If we wanted it to change forms to be more consistent with the others, we would distribute out that -5 and get -5x plus 75. Add 2 to both sides. Your slope-intercept form would be y equals -5x plus 77. That would be a hard one to graph on here because the y-intercept is so high up there, but it would look something like that. Try your problem. So if the landscaper needed to install a different path through the picnic area, what equation should he use? Try to get all the way to slope-intercept form and use Desmos if you need it. check your answer. So your equation should be y equals negative 5x plus 31. If you were thinking, it should have been the same slope as the one I did, because two perpendicular lines to one would be parallel to each other. But this one would go through 31 up, and it would look something like the line shown. In this lesson, we continued to learn about parallel and perpendicular lines. So parallel lines still have the same slope and different y-intercepts, while perpendicular lines have opposite reciprocal slopes. To make lines go through specific points, we're going to use point-slope form and then convert it to slope-intercept form if we need to. This means we need the slope and a point, and then to convert it, we would distribute to solve for y. So for example, if we wanted to create a line perpendicular to 3/2 x plus 5, but through the point 6,3, we would use opposite reciprocal slope, so negative 2/3, and then using point slope form, we would plug in our numbers, simplify it out, and our slope intercept form would be y equals negative 2/3 x plus 7. Had we wanted a parallel line, we would use the same process, but the only difference would be our slope would be the same as it was originally instead of the opposite reciprocal. So pay close attention to what type of line you need to make. So after this lesson, do you now know how to create a parallel or perpendicular line from given criteria, including points and given lines? If you're not sure, go back and look at some of the examples and how we were able to use Desmos to help. And that's it for lesson 2 on continuing our learning through parallel and perpendicular lines.